here for the last 2 years. Now we are going to be answering your questions soon, so be sure to drop them in the chat. This will be a chance to see the spacecraft up close before it heads to NASA's Kennedy Space Center, where it is set to launch in October. Now, drop those questions in because we are going to chat with Jordan Evans, who is the project manager on the mission. So let's get over here. Hi, Jordan.
Hi, Raquel.
Thank you so much for joining us today.
My pleasure.
So can you tell us more about the space we're in?
Sure, this space is a historic High Bay 1, so all of the largest planetary spacecraft and Earth orbiting spacecraft that Jet Propulsion Laboratory has built over the years have come from this clean room, going all the way back to the first robotic soft landings on the moon in the 1960s, through the Mars rovers, and now Europa Clipper, which we've developed in partnership with the Johns Hopkins Applied Physics Lab in Maryland.
And your role as a project manager, can you tell me a little bit more of that?
Sure. I mean, at the high level, I'm responsible for the overall technical, cost, schedule, and team leadership on this project. So day to day, that's really managing risk and balancing that risk across cost and schedule so that we can achieve the science objectives of this mission. It also means breaking down the barriers so that our team can get the jobs done that they need to do to get this mission on its way.
And how long have you been part of the Europa Clipper mission?
I've been part of Europa Clipper for 5 years.
And how many times have you been in this clean room?
On this mission, this is actually only my second time on this mission,
wow.
But I've spent a lot of time from past missions in this clean room and many others like it.
Well, I know you know a lot about the spacecraft, so can you tell us a little bit more about the hardware and the instruments we're seeing behind us?
Sure, yes. The first thing you see is this large cylindrical section from all the way towards the back coming towards us. That's the propulsion module. Inside that are two very large fuel tanks that hold our fuel and oxidizer. And then forward of that, this rectangular box, that's our avionics vault. That's a radiation protection device where the bulk of the computers on board the spacecraft are inside of that vault. And you can see all the wires that connect them. And then the tubes there, those hold the solar arrays that are currently at the Kennedy Space Center getting ready for launch. But in our launch configuration, they're stowed and tied down to those tubes. And then there's a center pyramid there you see, that's the solar array drive actuator. So the solar arrays put all their power through that, and that's used to steer the solar arrays towards the sun.
Can you give us an idea of how big those solar arrays are?
Yeah, sure. If you were to take our solar arrays fully deployed and put it up against the Statue of Liberty and put one end at her feet, the other end of the solar arrays would come all the way up to her crown. Not quite all the way up to her torch, but all the way up to the crown of the Statue of Liberty.
Wow, that is an amazing factoid that we have there. So I know that there's other areas that we can view more instruments and hardware, so can we go see it from kind of this angle over here?
Absolutely.
Okay, let's move over. I think right about here will be nice. So what can we see from this angle?
Sure, yeah, so this spacecraft is actually in the current configuration that we will be in when we fly over Europa. So what's facing towards Earth will be facing the surface of the moon Europa when we fly over it. So what you see here is this full suite of instruments at the bottom. On the left there, that is our imaging spectrometer that images the surface and actually can look at chemical composition of the ices. On the right-hand side are the suite of cameras, thermal imagers that look at a variety of wavelengths at the surface. We also have a couple of star scanners, those two cones with the red circles on there just above it. And those are imaging the star field so that the computers on board can compare it to what it knows the stars to be and knows where we're pointing. Further on up on the right-hand side in the middle, you've got the two instruments that face the direction we're flying so that they're actually tasting the atmosphere of Europa as we fly through, our mass spectrometer and our dust analyzer. And then all the way at the top on the right, you've got a set of antennas and sun sensors that are helping track the sun and communicate with Earth. And on the left are a couple of plasma sensors that are sensing the plasma environment around Europa.
And I'm also noticing some red hardware scattered about the spacecraft. Can you tell us more about it? Because I can see, I don't know if the audience can see it, it says please remove before flight.
Yes, yeah, anything with a red, those are called red tag items. So anything with a red cover, it's typically because we're trying to protect the hardware in the environment when it's around humans here on Earth, and those things are all flagged red so that they get removed. We of course have extensive lists to make sure that all the red tag items are removed. And then we have something called green tag items, which are the things that we install right before we launch too.
And I know that there's more to be seen on the other side of the spacecraft too, so love to head over there and have everyone see this angle too, because I think it's a special view from this side.
Yes, yeah, beautiful view. Let's go ahead and start at the top here. I didn't mention from the other side, that large 10-foot diameter dish at the top, That's our high gain antenna. That's used to communicate with very large antennas on Earth to send all our science data back from Europa while we're doing the mission. You see more of the cabling. In the center on the bottom, you see these cylindrical pieces. Those are pressurant tanks that hold pressurized gaseous nitrogen and help provide performance for our propulsion system. And then on the outside of that is a large plate that's actually a thermal radiator where all the heat that is being generated by the computers gets pumped through a fluid, just like your circulation system in your body, and then rejected to space out that radiator.
And now that we've seen the spacecraft, can you tell us more about how it will explore Jupiter's icy moon, Europa?
Sure. So, this mission is all about determining if Europa is a habitable environment. It's about the size of our moon, and yet we believe it has an ocean with twice the water of all of Earth's oceans combined. And so we're looking to see whether it is currently a habitable environment. Does it have water? We believe it does. Does it have organics? Does it have all the necessary chemicals for life? Does it have energy sources, either from a molten core like we have on Earth, where thermal vents are feeding the oceans, or from the radiation breaking down materials on the surface? And then also, has it been going on for a long time, a long enough period of time where life could potentially take hold? And we believe it's been simmering in this state for 4 billion years.
Now, to get all the way out there, I imagine there are some challenges that will be faced in that environment.
Yes, so Europa happens to sit right in the middle of Jupiter's magnetic field, and that magnetic field is a particle accelerator that creates an immense radiation environment. And Europa sits right in that radiation environment. So we end up just having to pick materials that don't break down and degrade in the radiation environment, and also electronics that are hardy to that radiation environment. We also have the cold of space, and it requires thermal blanketing that are built by human hands, essentially by tailors, seamsters that build these blankets and fit them around objects that are having to move as we do each of these flybys.
I've heard them once be described as winter coats for spacecraft.
Absolutely, yeah. I mean, you can zoom in and see there, this is our narrow angle camera, which is gimbaled in 2 directions, which means it's steering and taking images as we fly over. And you can see it's a form-fitting winter coat for that camera.
And can you tell us about the challenges that were presented to when building the spacecraft as well?
Sure, yeah. So challenges include having to survive the launch environment, the vibration, the noise inside the nose cone as we launch. Then the fact that when we launch, we're near Earth and it's nice and warm. We get out to Jupiter and it's very, very cold, and so you have to deal with those temperature extremes. I mentioned the radiation environment. And then this mission is unique in that it has all instruments operating at the same time every time we fly by Europa. And I didn't mention our big radar instrument, because that's out on our solar arrays currently in Florida. And so you have this radar that's putting these powerful pulses down to look at the ice-ocean boundary. And at the same time, those pulses can't impact the science that the other instruments are doing. And it's waiting for these faint responses back from the surface, and we can't let these instruments be emitting things that will swamp the radar. And so that was another big challenge.
And you've answered all my questions now, and I see some questions coming in through the chat, so I'm going to start reading them now, and if you have any questions you'd like to ask, drop them in the chat from where you're watching. So Ted on X wants to know, can you talk about the harsh environment that the spacecraft will be in? We just got that, so great, and how it will be protected. Anything else you'd like to add to that?
I can tell you that we have to put so much protection in here because every one of those flybys, this spacecraft gets the equivalent radiation dose of 100,000 chest X-rays. So protection is definitely important.
Very key for this. And then Rachel on LinkedIn wants to know, what kinds of images do we expect to get from Europa when the Europa Clipper arrives?
Yeah, so we've seen Europa from far away, from Galileo and Juno, and so we have cameras on board that have a resolution down to where we can see things that are only 1.5 feet across. So something the size, not that we expect to see a car, but something the size of a car would be multiple pixels, and we would actually get a really good image. So it'll really help us understand the geology and surface topography of Europa, understand how that ice might be moving around, if there are interstitial lakes, if that water is coming up to the surface. We ought to really be able to get some amazing images that will just open our eyes to a whole new world.
And around what year do we expect to see those images come through?
So we launch in October, and then we arrive in April of 2030. It takes about 6 months to start doing that dance with Europa. And so the images will be coming down as soon as we arrive in 2030, but those up-close images with each of these science flybys start in early 2031.
Great, and then we have another question coming in. Ghost on Instagram wants to know, will the information be sent back to our research centers as the mission goes along?
Yeah, absolutely. So with each of these flybys, all of the data collected on board goes through that very large high gain antenna and comes back to Earth through the Deep Space Network. The Deep Space Network has antennas all around the Earth, so no matter where the Earth is relative to Europa, there's a clear line of sight to send that data back. That data, once it reaches one of those stations, comes to JPL and then gets distributed to our mission control here and then to all of our partner organizations. We also have a mission control at the Applied Physics Lab in Maryland, and then the instruments science team members are actually all over the world.
And then V on X wants to know, is the spacecraft turned on right now, or are you just adding and adjusted pieces, which I think there's a spot over there where we can talk about the blue light and what it means.
Yeah,
okay,
yeah.
so
I'll follow you over
let's head
there. That's great.
Here, there's a place where we can really answer that question, how you know what's happening.
Yeah, and while we're walking over, I'll say that we've installed really everything that we plan to install at JPL, and so the next thing is prepare it for shipment and then get the solar arrays on. But there's a blue light over there that you might be able to see. There's actually multiple blue lights flashing. That blue light tells the people in the clean room that the spacecraft is powered on. So there's power being applied. You can see wires going up to where the solar arrays connect. And so there's solar array simulator power going into the spacecraft. And we're actually doing a test where the spacecraft thinks it's flying right now. And we're doing a test of its guidance, navigation, and control system to show not only that all the functionality still works with all our latest software upgrades, but that when we command it to spin to the right, that the reaction wheels spin up and it actually is spinning to the right. So that's called a phasing test. And so all of that's part of this end-to-end test of our guidance, navigation, and control system.
I like to think that Europa Clipper is doing its homework right now.
It is, yes.
And then we have Candace Grossman on Instagram wants to know, will it be able to find signs of life?
So we are definitely not a life detection mission. So signs of life, we're looking for habitability. We're looking to see if all of the ingredients are present to where it could be a habitable environment. The kind of signs of life that we might find, in an image or something, who knows? That's obviously a voyage of discovery. Again, we're really about, is this environment a place that could have life right now?
Thank you for that distinction. And then Snyder Derek on X wants to know, can you discuss how much vibration a rocket launch can affect the vehicle?
Sure. So if you think about the roller coaster videos and things where people's faces get, and fighter pilots, a few G's you really feel. 9 or 10 G's can make you go unconscious. This thing will see 9 or 10 G's in the thrust direction and a few G's in the sideways directions. And then there's the rocket noise, 140 decibels of rocket noise. So lightweight things like that high gain antenna and those solar arrays really start to vibrate. If you think about a rock concert, the louder the music, the lightweight things really start to take off.
So the testing for that is actually done in a different space. Can you kind of go over that?
Sure,
too?
yeah. So once we have that environment for our rocket defined, then we have a facility here at JPL where we put the spacecraft on a shaker table, which is exactly what it sounds like, and we put it in the thrust axis and we shake it up and down with the full frequency content that we would for the rocket, and then we put it on what's called a slip table and shake that table sideways and do both of the sideways axes, and then we put it in a concrete walled chamber with gaseous nitrogen powered speakers and blast it with 143 decibels because we had margin.
And seeing that it's back in here, I assume it passed the test?
Everything went great, yes.
All right, great. And then we have another question. Jacob's mom on YouTube wants to know, what is the most challenging part about assembling Europa Clipper? We touched on this before, but we have people tuning in again.
Sure, yeah. I mean, there's so many challenges. In assembling it, it's the fact that we're trying to put all of these really delicate instruments together in a robust way and hardy enough to survive these environments that it has to go through. And so we have to track every wire, every fastener, and because you might find later, oh, that wire was not as strong as we thought it was. Well, we know exactly where that wire was put. And so it really is about the methodical, build a little, test a little, make sure all along the way that the thing that's coming together is going to do the job we need it to do.
It's a great question. Again, thanks for sending that in. So D-Power2 on X wants to know, is the high level of radiation around Europa likely to reduce the possibility of finding life?
It's a great question. So, and that question gets asked a lot. I'm not a scientist, but the scientists believe that radiation, for one, water is a great radiation protector. When we talk about humans in space, talking about encasing them in water as radiation protection. So theoretically, that radiation is not making it into the ocean. But even on the surface, that radiation is breaking down the chemicals on the surface and actually creating the kinds of energies that might be necessary to feed life.
Great. And then Opal Guy on YouTube wants to know, what do we hope to learn at Europa that will help us understand Earth better?
That's a great question. I mean, Europa, we believe, is an ocean world. And so beyond the technologies that we use to answer these scientific questions that certainly pay dividends on Earth in medical devices, in the cameras in our cell phones, things like that, understanding another ocean world will help us better understand our own, the processes that are happening there, ice melt, that environment, how radiation affects it, all gives us another data point, a second data point for better understanding Earth and how we can take care of it.
We have more questions coming in. We have Logan G1X on X wants to know, will you be able to see anything under Europa's ice?
So another great question. So we haven't that ice penetrating radar, and radar like sonar gives us sort of grainy images. So yes, we might see interstitial lakes. In that ice, we might see pockets of liquid water in that ice that we would be able to see with the radar. As well as the ocean boundary. And so anything in there, if there's a rock or something in there, that we get a radar return that we would likely be able to see.
Very cool. And then we have Ashwari Official on Instagram wants to know, how much time did it take to make and how many chances to succeed on its journey?
Another great question. So we really started the design in earnest in 2014. So we're about 10 years into that. All the parts started being built in 2016 through 2019, 2020. By 2022, we were starting what's called full system integration and test, where all the parts got delivered to JPL and we're starting to test it as a system. And so that's the timeline for coming together. In terms of the things that can go wrong as we go on our journey, every step of the way from the launch through trying to deploy the solar arrays, establishing communications with Earth, entering the orbit at Jupiter to start the Europa science. There are a lot of opportunities for things to go wrong, and on a mission like this, we try to anticipate as many of those as we possibly can and ensure that the system is not only redundant if something fails, but also that there's fault protection to deal with those events. We've tested this system from launch all the way through a simulated flyby, and during that, in what we call off-nominal testing, we're pulling wires out, we're turning off computers inadvertently, and watching the spacecraft attempt to fly through it to make sure that it's handling those failures the way we designed it to.
Sounds like quite the journey for it. So we have Courtney on LinkedIn who wants to know, what's the best part of your job?
Oh, the people. I mean, this job is nothing if it weren't for the people. The passion of the people, the fact that every day they're encountering challenges, they're figuring out their creativity and overcoming them, their ability to communicate any residual risk that might be there, the various options, and just the joy that we all get from being able to be involved in such an epic endeavor.
Definitely hear your passion about everyone you work with as well. Shirag on LinkedIn wants to know, do you add new technology or change your mind on hardware choices as the spacecraft comes together?
Another great question. So NASA's typical life cycle is when we finish the preliminary design, any new technologies have to reach a certain level of maturity. So at that point, we've locked in the technology. Sometimes we got it wrong and those technologies go south on us. And so we do have to make decisions late. It's typically not to now adopt yet another new technology. It's to regress to maybe something a little less technologically advanced.
And then we have a few more questions coming in here. Kari Minoz9 on Instagram wants to know, why does it take 6 years to get to its destination?
So Europa and Jupiter are a long ways away. So that journey is 1.8 billion miles that we have to go with the trajectory you have to take. So we're using the biggest rocket that can accommodate this at the time that NASA selected it. And that rocket still can't get us there very quickly. So we end up having to do gravity assists. We go by Mars and slingshot off Mars 4 months after launch. Then almost 2 years later, we slingshot by Earth, and each of those gives us a little extra energy. And that last slingshot, it's still another 3 years out to Jupiter, so 5.5 years total.
And then C. Guarino 10 on Instagram wants to know, will the Europa Clipper have a lander?
Europa Clipper does not have a lander, so it is purely an orbiter. Again, it can interact directly with the atmosphere and the plasma environment, but it's not a lander. That's the future mission study potential for NASA.
All right, thanks for that one. And then We have, let's see if we have one more coming in here too. Thanks for all these great questions, by the way, for everyone that is coming in live. We have two final questions coming in for you, Jordan. So I'll get to them in a moment. Just love seeing this spacecraft from this angle as well, because usually you said there's supposed to be blankets on here that we get to see it this way because of testing.
Yes. Yeah, so that you can get a sense of the complexity that goes into this and the ability for it to do the kind of fault protection that it does by just looking at the amount of wires and connectivity. And then all that copper tape is to help protect all those signals from that harsh environment at Jupiter.
It's a very unique view. Okay, we have our questions coming in. When is Europa Clipper expected to leave JPL for launch to Cape Canaveral?
So in late May, we will be packaging up in a shipping container and putting it in a C-17 military aircraft and flying it, landing it on the Space Shuttle runway at Kennedy Space Center, end of May.
Great. And then Lauren's Detail on X wants to know, what motivates you on your space exploration journey?
Wow, I've wanted to do this since I was a little kid. Nah, I'll try not to get emotional. And so getting to be involved in science and rewriting the textbooks and interacting with the kind of crazy creative people that I get to every day, it's like going to Disneyland for me every day. It is very motivating.
Rewriting the textbooks is a great way to put it. Thank you so much for your answers.
My pleasure. Thank you. Thank you for all the questions.
Yeah, thank you everyone for all the great questions that were submitted today. So to learn more about Europa Clipper, you can follow at NASA JPL on X, Facebook, and Instagram. And you can also follow Europa Clipper at Europa Clipper on X and Facebook. Thanks again for watching.